Hello, it's me. I was wondering if after all these years you'd like to meet to go over everything. They say math is supposed to heal ya, but I ain't done much math. So hopefully this weekend you were able to enjoy Adele's new CD 25 as much as I was. Um, and also hopefully you were able to get your homework done. So this is, I said before, I signed a really important activity. I really hope many of you did it, though I'm skeptical of some of you. Um, so in this particular activity, if you hadn't read it, originally they create lots of land that are squares. Now they don't tell us how long each side is, but hopefully you realize that it can be represented by an image like this. We don't know the length, so we call it X. We can call both sides X because we know they're the same. So this is our original plot of land. And in question one, it says, the developer wants us to mix it up a little bit. So what if we extended each side by a little bit? Specifically, what if we extended the east-west or the horizontal direction by 3 meters and the north-south direction by 4 meters? You would get a lot that looked like this. Oh, I think I actually misspoke the 3 and the 4. Sorry about that. Anyway, so the question is, relative to the original area, what's this new area? And it's not necessarily easy to figure out, but hopefully you're able to make sense of it during your homework. And that is sort of, how do I get the area of that new blue shaded area? Because I know the area of the white square is just x squared. How do I get the area of the rest? And so for number one, now might be a good time for a volunteer to go up and show how they did it. So you can just pause me right now while someone shows what they did. Go ahead, volunteer somebody. Don't make me call on Joe Buffano. Okay, pause this video. Okay, hopefully you actually paused it and somebody showed it, though I am skeptical that you just kept the video playing. Anyway, here's what it maybe looked like if you broke it down. Something like that. So the cool part here was the sort of breaking down into these 3 rectangles from what was that one like L shape. And you can see the 3 sub areas. Well, this has a width of x and a height of 3, so it would have an area of 3x. This has a width of 4 and a height of 3, has an area of 12, and this one has a width of 4 and a height of x, so it would have an area of 4x. And you can sum them all together to say the area would be x squared plus 7x plus 12. And now here's the critical piece that might seem obvious. And what we're showing is that x plus 4 times x plus 3 is the same as x squared plus 7x plus 12. To think about this using an example we already know with numbers, if we had a rectangle that was, say, 9 by 4, well, we could just call that 36. And then anywhere we saw a 9 times 4, you could replace it with a 36. And because they're equal, you would get the same exact solution. And similarly, whenever you saw 36, you could replace it with a 9 times 4. It goes both directions. I know that seems obvious, but it's going to be important to where we're headed. So, right, the whole point of this picture, this area model, was simply to show that those two things were equal. That the left side was base times height, or length times width, and the right side of this equation is the area. And we know that length times width equals area. So these things are equivalent. So make sure you discuss the last 2 problems because they often get a little bit tricky. And if there's any problems before that you guys feel like you need help on, you can go over those also. This should take you guys around 10 to 30 minutes to talk about. And then when you're done talking about it, please pause it actually now. I think you actually will. And then you're going to go on to the next activity. So discuss and move on and unpause. So the very next page, page 295, is going to be your homework. So you can skip that for now, and that'll be your homework due tomorrow. Views of the distributive property. A lot of you guys, all of you guys have heard of the distributive property before. What I really like that this book demonstrates is often if you guys were asked to multiply 73 times 56, if you were taught the way I was taught, and this is how most of you were taught, you would do 6 times 3 and get 18. You carry the little, put the little 1 up there, and then you put 6 times 7 is 42. Well, plus the little 1 up there, you get 43. Then you bring down a 0, and who knows why you bring down a 0, but the teacher said bring down the 0. And you do 5 times 3 and you get 15. You bring down the 5, carry the little 1. 5 times 7 is 35, plus the 1 is 36, and you add those 2 up. So that's the way most people learn how to multiply multi-digit numbers or double-digit numbers. What I hope you realize is there's actually 4 pieces of multiplication that went into that. And what really happened originally is you did this, 6 times 3, well, that's just 18. And then when you did 6 times this 7, hopefully you realized you really just did 6 times 70. And that was represented in the algorithm because you moved over a space. So you got 42 here. Well, that's just 4 hundredths, 2 tenths, and a 0. And then you wound up doing 50 times 3, and you got 150. And then 50 times 70, which is 3,500. Then you added up those 4. So you like combine these two with the way you probably learned how to do it and combine those two and added them. But hopefully you realize that there was actually 4 pieces of multiplication you were doing there. Now it can be represented visually, and this is how kids nowadays learn how to multiply double-digit numbers, and it's actually way better. So 73 can be represented as a 70 and then 3 more, and then 56 as 50 and then 6 more. And we're simply just going to get the 4 sub areas. And hopefully, you guys can see the connection between what we did in the last activity and this activity. And then you can just say 73 times 56, or, base times height is going to get me the area, and they're equal. All right, so finish that activity, and then we'll talk about this activity. So again, now would be a time to pause. So go ahead and pause it right now while you do the last activity. That shouldn't take you that long. I would only guess like 15 minutes or so. All right, pause. All right, so this is actually a POW from year 1. I know Robbie started this. I think he's the only one, but I don't think he finished it, so I don't feel too bad assigning it. You don't need it. I'll just read it aloud. Consider the case of Corey Campbell, the enterprising but eccentric owner of a small banana grove in a remote desert oasis. Corey's harvest, which is worth its weight in gold, consists of 3,000 bananas. The marketplace where the harvest can be sold is 1,000 miles away. Corey must walk to the market, but she can carry at most 1,000 bananas at a time. Furthermore, being a camel, Corey eats 1 banana during each and every mile she walks. So Corey can never walk anywhere without bananas. So the question I want you guys to figure out is, how many bananas can Corey get to the market, or what's the most amount of bananas Corey can get to the market? Now, if you first tried, it might sound impossible because she puts 1,000 on her back, she walks, by the time she gets there, she's eaten them all. So I will just tell you the way to make this problem work. I don't think I'm giving it away here. Is she's allowed to drop bananas and then walk back and get more bananas. So she could, let's say, put on 1,000 bananas on her back, walk 50 miles, drop 900 of them, because she would need 50 then to walk back to the oasis. So she's now moved those 900 bananas 50 miles, and then she can pick some up as she walks, like they're not going to go bad or anything like that. So if you don't drop off bananas, then you'll never figure this problem out. So you might not finish it today, but do this until the period ends. And then if you somehow do finish it, I will tell you the answer is somewhere between 300 and 1,000, the best answer. If you do finish it and you feel confident, then you can start working on your homework, but I have a feeling you'll work on this until the end of class and probably sometime tomorrow. Okay, good luck, guys, and I will talk to you later.